How are you doing?
I'm good, Master.
Then Shaba, Irene, Shaba, Irene, how are you doing?
I'm fine.
So today, as you can see, we're having our lesson of chemistry, senior 2. So I want to take this opportunity to welcome you from the weekend. And before we do anything else, let us first invoke God to come and be amidst ourselves. Can we have someone to give us an opening prayer as we wait for our friends to join in? So far we are around 11 people, but we hope for more to come in. So, can we have a volunteer? By show of hands, you can lead us in prayer. Yes, Irene.
Humble yourselves and we pray. Heavenly Father, we want to thank you for the night you gave us. We want to thank you for a very beautiful day you have given to us. As we are going to start our lesson, we call upon you to bless us and help us get what the teachers are going to teach us. In Jesus' name, I've been able to pray.
Amen. Thank you so much, Irene, for that wonderful prayer. And we hope that God has heard your prayer and everything will be granted. So I welcome you once again to this lesson. This is senior 2 chemistry. Because in case you're here and you're not in senior 2, so please, you can cross-check on the timetable and see which class or which lesson you're supposed to be having. So we shall continue from where we stopped last time. We're looking at carbonates and hydrogen carbonates, and unfortunately we didn't finish them. So today we are here to continue and see if we can finish. So before we kick off, can we have someone to remind us what we covered last in the previous lesson? Anybody to remind us what we covered in the previous lesson? Anything that you still remember about the previous lesson? Anything that you can remember? By show of hands. Anybody to share with us what we looked at in the previous lesson? That was last week on Tuesday. You can raise up your hand or you can use the chat. But I think it is better if you raise up your hand and we hear from you. Annette? Annette, can we hear from you? Yes, Isabella?
Good morning, teacher.
Good morning to you.
We studied about carbonates and hydrogen carbonates.
Okay.
Carbonates are salts derived from carbonic acid.
Yes, please. Is that all?
No, their property, they can also be dissolved. Some of them can be dissolved in water.
What are those ones? What are those examples of the carbon that dissolve in water?
Potassium carbonate, sodium carbonate, and ammonium carbonate.
And ammonium carbonate. Thank you. Thank you, Isabella. So we need another person like Isabella. Now let's hear from a gentleman and we'll see if the gentleman we have here can be our guides. Conrad. Conrad, we are making records, so I think we shall take you as refused. And remember, our lesson is live on YouTube, so we shall remember you in the future. So it seems Conrad is unable to talk to us. Lastly, we can have let's have Elvin. Elvin, unmute.
Yes, teacher.
Yes, please. Share with us what you can remember in the previous lesson we had last week. Anything that you can still remember in what we covered previously.
Previous lesson was talking about carbonates and hydrogen carbonates.
Yes, please. What exactly do you remember about carbonates and hydrogen carbonates? It could be a property, it could be maybe a definition, it could be anything. Meanwhile, as Elvin remembers, let's hear from Ashley.
Good morning, teacher.
Good morning.
Good morning, teacher. Good morning.
Good morning to you.
Good morning. Last week we learned about carbonates and hydrogen carbonate. You told us that they were salts derived from carbonic acid. Then we learned about the properties, especially solubility, which I understood the most. You told us that apart from potassium, sodium, and ammonium carbonates, all the others are insoluble in water. Then we also talked about hydrogen carbonates, and you said all solid hydrogen carbonates are soluble in water, except from sodium hydrogen carbonate, which is only slightly soluble. Then we said that hydrogen carbonates of metals lower than magnesium in their reactivity series do not react, and hydrogen carbonates of calcium and magnesium only exist in solution form.
Okay. Thank you so much, Ashley. I think you are now the role model of our class. So those who refuse to give us or share with us, or next time be like Ashley. Ashley, thank you so much once again. Alright. So actually talked about everything that we shared in the previous lesson. So now I want us to continue and look at things that we didn't look at that time. So having looked at the carbonates and hydrogen carbonates, we need to find out how they can be tested. How they can be tested in the laboratory. When we say testing, it is like confirming. How would we confirm that whatever we are dealing with is a carbonate or hydrogen carbonate? So one, if the sample is a solid. What do I mean when I say if the sample? When I say if the sample, it means that it can be either, the sample can be either a carbonate, or it can be a hydrogen carbonate. So that is what I mean when I say a sample. And we are saying that if the sample is a solid, in other words, if you have a carbonate or a hydrogen carbonate which is in solid form. So whenever we are looking at these experiments in a lab, we normally look at three things. One, carrying out the experiment. One, we look at the procedure. When I talk of the procedure, those are the steps that we follow to have the experiment done. Procedure first, those are steps. For example, if you are going to cook food, those who cook, you have procedures that you follow. There is no way you can put food on the fire before putting the food in the saucepan. Though sometimes people do it the other way around. So procedure, those are the steps. Then having followed the procedures, then we look at observations. Observations, those are things, all the changes you see taking place. Normally when you look at observations, we look at color changes. For example, you might be having a green substance or a green solid, it turns to a black solid. That is an observation. The things you can see with your naked eyes. So we look at color changes, even the state changes. We can be having a solid, then turns into a liquid. That is an observation. We can say our solid turned into a liquid. So that is also another change. Another change could be maybe the size. We had a small size of our substance, now it became big. We had a big one, now it became small. So those are the changes or the observations. And then lastly, for any experiment, having gone through procedures, observations, then you have to conclude. So you must be having what we call a conclusion. Normally we call it a conclusion, others call it a deduction. So conclusion is to conclude, I think, in English. So you can find out any dictionary meaning. Conclusion is like the summary or confirm what you've been doing. I think you've done that if you've done compositional writing, I think, summary writing. Even history, all your points you have to conclude. Am I right? Someone to prove that I'm right or wrong can send me a message or no, that we all be on the same track. Okay, so we have conclusions in history. So also in chemistry, under experiments we must conclude so that we can be very sure. All right. So when we have our sample as a solid, the procedure is we have only one procedure, or we have only one step. So what we do, we add a little dilute acid to the solid substance under the test. When I say the solid substance, I mean this time we are testing for a carbonate or hydrogen carbonate. So the sample test or a sample solid, it will be one of the two, either a carbonate or hydrogen carbonate. So it's the one which is under the test, and we are adding a dilute acid. We looked at acids that which can react with carbonates. Can someone remind us of those acids? The acid that react with carbonates, we talked about them in the previous lesson. Someone can. Yes, Ashley. Ashley,
Nitric.
can unmute.
Dilute nitric acid.
Dilute nitric acid, yes. Let's hear from Amani.
Hydrogen chloride.
I beg your pardon?
Hydrogen chloride.
Nitrogen chloride. Thank you for trying. But we don't have that acid. Stella.
Dilute sulfuric acid.
Dilute sulfuric acid. Okay, another one, lastly. I remember there were like 3. Who can tell us what Amani was trying to say? Okay, so someone here is saying hydrogen chloride. Hydrogen chloride is a gas, it's not an acid. Isabella says sulfuric acid. So we also had dilute hydrochloric acid. Remember, when we are dealing with this acid, make sure that all of them are dilute. If it is a concentrated acid, then it's a different story. So if you asked which acid, you have to state its state. Is it a dilute acid or a concentrated acid? Yes, Joan. Joan, it's like you have something to say. Okay, let's continue. So we are saying add a little dilute acid to the solid substance under the test. So here you have to choose. We have to choose one of the acids we mentioned, and we normally use dilute hydrochloric acid because we want to avoid forming another precipitate, another solid. Take an example. If we use the dilute sulfuric acid and we are likely to form an insoluble sulfate. So here we can put dilute, maybe hydrochloric acid. We can put dilute hydrochloric acid, or we can put dilute nitric. Then we add it to the solid substance under the test. Then we go to part 2, that is the observation. Observations, I say, that is what you see, and what we see can be in different, can be color changes, can be the state changes, can be the size, can be anything, as long as it is a change. So what do we see? We say that effervescence occurs and off bubbles. I'll use an example. When you open a bottle of soda, we tend to see some small bubbles coming from the bottom of the soda. So those are what we call effervescence, and at times the sound that is made by those bubbles in the bottle of a soda. I hope all of us have ever taken soda. Fizzing sound that comes from the bottom. So that is exactly what happens when you add a dilute acid to a solid containing a carbonate or hydrogen carbonate. And we are saying a colorless gas that turns lime water milky. And when we are looking at carbonates, we said that whenever they react with acids, they form a colorless gas, and that gas is always carbon dioxide. So all of them, whenever they react with a dilute acid, they have to produce carbon dioxide gas. But remember, now we have to confirm that the gas being produced is carbon dioxide, and also said that we can confirm that the gas is carbon dioxide when we use lime water. So can someone remind us, what do we mean when we say lime water? What is the chemical name of lime water? What is the chemical name of lime water? John? Joan? We've not had anything.
I forgot.
About forgotten to lower her hand. Here from Nwamanya, please unmute. What is the chemical name of lime water?
Calcium hydroxide solution.
Calcium hydroxide solution. Thank you. So in other words, we are saying that effervescence occurs and a colorless gas that turns calcium hydroxide solution milky is given off. And which other word can we use apart from the word milky? Which other word can we use? Yes, the answer, which is calcium, saying Maureen. Michigan is here. We can't get to Maureen. Estella?
White precipitate.
White precipitate. Thank you. So we can either call it milky or we can say a white precipitate. Thank you so much.
Yes, guys, can you hear me? Yes. Oh boy, can you hear me?
Yes, teacher, I can hear.
All right. As the teacher comes, can you be reading what is being displayed on the screen? Testing for carbonates and hydrogen carbonates. Yes, oh boy, read for us. Isabella. Yes, Isabella, can you read for us?
Testing for carbonates and hydrogen carbonates.
Okay, part A.
If the sample is a solid, you add a dilute acid to the solid substance under test.
Okay, that's saying that in case you want to test for carbonates or hydrogen carbonate, can you mute? You can mute. Thank you so much. Now the statement is in the laboratory, in the chemistry laboratory, sometimes you would like to find the presence of carbonates and hydrogen carbonates. Now, if they have given you a sample that is in solid form, solid means something that is tangible, something you can be in crystal form, or yeah, definitely crystal form, then what you do, you add dilute sulfuric acid to the substance under test. Yes, you add. Then there will be some observation. The moment you know sulfuric acid, it is an acid. So when you add it onto an element or some elements in group 1 or group 2, you know there's some reaction that will take place. Now what will happen? Yes, Olivia, can you read for us? If you add it, what do you think will take place? Yes, what will be the observation, Isabella? What will be observed?
Emphasis occurs on the colorless gas that turns lime water milky, which is carbon dioxide is given off.
Exactly, thank you so much. So they're saying if a solid, the sample they have given you is solid, and then you add a dilute sulfuric acid to it, what will be observed is there will be some colorless gas that will turn lime water milky. That is carbon dioxide will be given out. It's carbon dioxide that will turn lime water milky. That is test number 1. So when you're doing the experiment in the computer lab, in the chemistry lab, and they give you a solid sample, then you add dilute sulfuric acid to it, and there are a colorless gas involved that turns lime water milky. Then you say, okay, there is a presence of carbonate. Is it okay, Isabella? That is part 1, if you're testing for it. Now, part 2, okay, let's look at part 2. How do you test? Yeah, let me see. Now, conclusion. Now, there will be conclusion. In chemistry, I think it's divided into 3 parts. There is testing, observation, and the conclusion. That's what will always happen when you are doing an experiment. Yes, Ashley Atino, what will be the conclusion?
This shows that a carbonate or hydrogen carbonate is present.
Yes, it shows that the hydrogen carbonate is present because there will be colorless gas will be involved that will turn lime water milky. That is true. Then part B, Atino, Ashley, can you read for us part B? When they have given you in solution form, solution means in form of a liquid, what do you do? How do you test for the carbonate?
2 centimeters cubed of a test solution, add 3 drops of lead to nitrate solution followed by excess dilute nitric acid.
Yes, you are testing for carbonate, but in liquid form. So you 2 or 3 centimeter cube of a test solution that they have given you, add 3 droplets of lead 2 nitrate solution followed by excess dilute nitric acid. This time we are not using sulfuric acid, but we are using nitric acid. Is it okay, Atino?
Yes.
Yeah, and in solution form. So that's what happens. Now, after adding that, what will be observed? We have said is divided into 3. What is the observation, Ashley?
White precipitate is formed and the precipitate dissolves in excess nitric acid with effervescence.
Okay, yeah, the teacher is back. Oh my God, let me now make the teacher a co-host. Yeah, I'm so happy he is back. Atino, thank you so much. Thank you so much. Okay.
You're welcome.
All right, let the teacher take over now.
Okay, thank you, Mr. Charles.
Yeah, you're welcome. Can I stop sharing my screen?
Yeah, it's fine, it's fine. So remember, sorry about that. So we're still here. We had looked at the observation and we're explaining what we mean by the keywords we had here, like effervescence. Then Carbonates gas, we also got another name for lime water, and also another word we can use instead of the word milky. So once again, whenever you have a carbonate or a hydrogen carbonate, then you add their dilute acid, and a carbon dioxide gas must be produced. Yes, Conrad.
Teacher, teacher.
Yes,
The other
please.
the chemical name for lime water is called calcium hydroxide.
Yes, thank you. Thank you. It is calcium hydroxide. Thank you. So after the observation, we go to conclusion. Having looked at this, having looked at observation, then we can draw our conclusion from the observation. So what could be our observation, our conclusion according to what I've said? So you carry out the test, following the procedures, then you draw your conclusion according to your observation, or maybe we can say findings. So who can predict the conclusion? Yes, Ashley. Ashley, please, your hand is up.
Teacher, the conclusion is this shows that a carbonate or hydrogen carbonate is present.
Yes, can. So Ashley said
Present.
form. So since we have a solution, we always measure solutions in volume. So in volume we normally use to 2 centimeters cubed of a test solution. So in this case, we shall have our solution containing a carbonate. We shall have our solution containing a carbonate. We add 3 drops. We add 3 drops of lead 2 nitrate. We add 3 drops of lead 2 nitrate solution, followed by excess dilute nitric acid. Followed by excess dilute nitric acid. It seems Joanita has something to say. Yes, Joanita. Joanita?
Excuse me, sir. I've just joined, so
Yes,
I don't know. I don't know what we are looking at.
Okay, sorry about that. But you keep in line. You keep on the line, then I'm sure that by the end of the lesson, you'll be knowing what we are doing. Thank you. Someone is saying that my voice is too low. It could be the network issue. So once again, here we are having 3 things to do. 1, we must be having the test solution, which contains the carbonate. Then again, we need lead 2 nitrate, and also we need dilute nitric acid. So we need 3 solutions in this case. So we need to look at what happens when all these are mixed up. What happens? Do we have anybody who can predict what will happen, or what we are likely to see? What could be our observation? Anybody to try? Anybody to try? What are we likely to observe, or what are we likely to see when we have our lead 2 nitrate added to the solution containing the carbonate, followed by dilute nitric acid? Okay. Let's hear from Juliet.
A white precipitate is formed.
Juliet.
A white precipitate is formed.
A white precipitate is formed. Thank you. Missing in your answer? What you said is true, but there is something missing. Say to yourself. Let's hear from. I hope that is the right pronunciation of your name. Estella.
A white precipitate is formed which dissolves in the excess nitric acid.
Thank you so much, Estella. So we shall form a white precipitate that is going to dissolve in excess dilute nitric acid. Precipitate is formed and you stop there. There you are having an incomplete observation. So that white precipitate being formed, it is going to dissolve in the excess dilute nitric acid. Thank you, Isabella. Isabella also says that white precipitates are formed and they dissolve in excess nitric acid. Thank you. So let's look at that observation. So our observation is white precipitate is formed and the precipitate dissolves in excess nitric acid with effervescence. Okay. Remember, we are having a carbonate, so we must be having that effervescence. So what do you think would be the effervescence this time? What is in that effervescence? By show of hands. I don't know whether Stella you're going to give us the answer or you forgot to lower your hand. So what do you think is this effervescence? Like the way we looked at it in the previous parts. Conrad, I don't think that is my network, given that other people can hear me. Let's hear from Isabella.
Carbon dioxide.
Isabella?
It is carbon dioxide.
So effervescence is carbon dioxide. Thank you. So people are saying carbon dioxide. Thank you so much. So this is now our observation. And from there we can conclude that. What is our conclusion? What is our conclusion? What is our conclusion on that? What is the conclusion? By show of hands, you can tell us what is our possible conclusion to that. What are we testing? And what is our conclusion? It seems like we have only one person here. Others are supervisors. Should I say I have many supervisors here? Maybe others want me to first say out their names. Linda. Linda Pretty. Linda Pretty. Ladies and gentlemen, Linda Pretty has refused to talk. Yes, Cravens.
I think the conclusion is it shows that a carbonate is present.
Okay, thank you so much. So our conclusion is that a carbonate is present. A carbonate is present. So members, what we are looking at even at this time, there are same things we shall look at when we go to practicals or chemistry. When we start doing practical notes and we keep revising them so that we don't forget. So here we have our NB. Sometimes we can use barium nitrate solution or we can use barium chloride solution. So if I may ask, what do these three have in common? What do these three have in common? The barium nitrate solution, barium chloride, and lead 2 nitrate solution. What do they have in common, according to you? What do you think they share? Barium nitrate solution, barium chloride solution, and lead 2 nitrate solution. What do you think they have in common? Who can tell us? We are trying. Now, when you're in class, it's not about having the correct answer. You can give us what you think. If it is correct, we shall say it is correct. If it is not, we shall guide you. Yes, Denise. Please, anybody who can tell us? Yes, Shina?
I think they are all dilute acids.
Shina, please talk to us.
I think they
I
are
don't know whether it's my network or yours. Can we have another member? Another person can try? In the chat, they are all in liquid form. Isabella says that they are all in liquid form. Thank you. That is one. Number two. Or we can say that what would be they are all in solution form. What else do they share? One last person. So to save time, when you look at these three compounds or salts, barium nitrate solution,
Yes, members, the teacher will join. I think he's having some technical problem, but he's going to join. Stay calm. Meanwhile, as he comes, senior two members, I hope you now know our YouTube channel. I do encourage you to go and subscribe onto our YouTube channels, because after the end of this program, we shall be uploading video tutorials, and the only way you will get notification is if you have subscribed. So if you have not subscribed, please, you can check on Google Classroom. There is a playlist. After watching a video, you can just subscribe to our channel so that you receive updates. Yeah, we shall be uploading very many videos. And if you have any question, always as the teacher comes, you can also ask questions concerning this program. Okay, the teacher has also come. Thank you so much, Teacher Osward. I'm still telling them that they should not forget to subscribe onto our YouTube channel. You can continue.
Okay, thank you. To add on that of the YouTube channel, today I'm going to, there are some things I need to, to explain more because of the time that we always have. Now we always have only 1 hour and at times I just summarize something. So I want to make a short video explaining more about what we have covered on our YouTube channel. Mr. Charles, you can share the link. Then they'll be able to find the video and do the exercise as well. So once you reach the Google Classroom, you find a link which will take you the video. You watch it, then you'll be able to attempt the exercise. Yes, Sarah. Sarah,
Excuse me,
you
Master.
opposing what you have said? Yes, sir.
No, I have a question. I
Yes,
didn't
please.
get the similarity. I didn't get the similarity between the three.
Okay, I'm going to repeat that. Mr. Ghana is saying that teacher, we say that the effervescence in that solid part is a bubble or sound when you open a soda, but in solution form you say that it is carbon dioxide. What is their difference? Even with this solution form, when we add excess nitric acid on addition of nitric acid, that's when we shall have the effervescence or that sound of a soda after adding dilute nitric acid. The sound comes in when you add an acid. That's when the sound comes in. But remember before we didn't add an acid. Here we have added we've added let me say, first delete this. When we have it in solution, we first added lead to nitrate solution, which is not an acid. That's why we are unable to hear that sound or to have that sound. I will send you a video. I will share with you a video showing how it looks like. Then we shall hear the sound when we add a dilute nitric acid. Not so. That's here. Here, if I'm to write, because of time, maybe I will put it in the other video I told you. The carbonate, lead to nitrate, and also the nitric acid in the video. Because of time, I'm unable to share that right now. So Teacher Charles has shared with us the YouTube channel, the YouTube link. Please make sure you follow it and you subscribe. And even all the other videos from the beginning, they are all there. For members who joined us late, please make sure you go there and you subscribe and you'll be able to watch all the videos, you comment, then you come back to us what you don't understand. Some hands. Yes, Tendo. Tendo. Yes, Prudence. I think these people are unable to talk to us.
Teacher, excuse me, teacher.
Yes, please.
I just. Teacher, you hear me?
I'm getting you clearly.
I just wanted more explanation about testing carbonate.
Testing carbonates. Okay, because of time, I might not be able to repeat, but I'm going to make for you a short video, then you'll be able to
Okay, sir.
watch everything.
Thank you, sir.